Hey y'all, it's me, Miss B. Today we're talking about how to add and subtract radical expressions. So take a second and go ahead and try to match these like terms on your own. All right, so you should have said that x goes with x. Well, we can do some fancy ones here. Then we have 3x squared with this 4x squared. 4y squared goes with 2y squared, and 3x to the third goes with 4x to the third. All right, in order to have like radicals, similar to like terms, we have to have the same base and the same exponent. And by base, I mean, dang it, I shouldn't have said base and exponent. I should have said radicand and index. Okay, so we've got radicals, like radicals with just numbers. So the 2's, those are our radicands, are the same. And notice that they don't change. And we also have the same root of 2 on this one, same root of 2, or I'm sorry, same root of 3, same radicand of 7. Here, 5xy and 5xy, same radicand, invisible 2's on both of these. Same index, 9x squared y and 9x squared y. So that is how we can add radicals that are alike. Okay, so let's go ahead and talk about how to simplify. So first we want to simplify the radicals where we can. In this particular problem, it's already been simplified. Okay, so then we want to check to see if the indices or the indexes and radicands are the same. So check this problem. We've got 2 invisible 2's, so that's good. So I'm just going to write index, check, and then radicand is 5x in both of them, so those are the same. Okay? Then we can add or subtract the coefficients if possible. So we have 3 and 2 here, so I'm going to do 3 minus 2 is 1, and then my radicand and index stay the same. They just get carried together. So my final answer for this one ends up being square root of 5x. All right, so for this one here, I've got an index of 2 on both of them, but I have radicands of 7 and 5. So, and they don't simplify any, so this is actually, we can just write simplified. It's already simplified for us. Okay, this next one here, I've got same base, different indexes. I'm going to go ahead and go back and say our base, or let's say index, check, radicand, doesn't know. Okay, so this one, our index is different, but our radicand is the same, but I have to have the same index and I can't simplify, so we are just going to say that this is already simplified. All right, this one here, go ahead and think about it. Got different indexes, so simplified. 5, go ahead and try that one. Got the same index and we have the same radicand. So I'm going to do 3x plus 4x is 7x. And then that right there is my final answer. What about 6? Same radicand, same index. Oh. So then I'm going to do 17 minus 15 to get 2 fifth root of 3x squared. Make sure you make those really small because this means something different than this, okay? This is not the same thing. This right here is our final answer. So make sure those indexes are really small. Let's kick it up a little bit. Okay, so let's go ahead and simplify these. I do have square roots, but I can simplify them. So 12 has a perfect square of 4 in it. 75 has a perfect square of 25 in it. 25 times 3 is 75. And so then I'm going to go ahead and simplify. So square root of 4 is 2 radical 3 plus 5 radical 3 minus radical 3. So my indexes of 2, those invisible 2's, are the same. I have 3 as my radicand, so I can simplify to be 2 plus 5 minus a 1, invisible 1 there. So we get 6 radical 3 as our answer. Oh, okay. This next one. Okay, kind of tricky because we have to find perfect cube this time. I'm going to go ahead and write out some perfect cubes over here to the right. So we've got 1 to the third is 1, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, 5 to the third is 125, and we can stop there. I don't think we'll need to go any further. I would go ahead and write those down as well. And remember, your perfect cubes are the ones that are on the right here, not the ones that are on the left. All right, so 250 has a perfect cube in it of 125, and 125 times 2 equals 250. 54, what perfect cube goes into 54? Should have thought 27 and 2. And then 16 has a perfect cube of 8 in it times 2. All right, so then cube root of 125 is 5. Cube root of 27 is 3. Cube root of 8 is 2. Okay, so now that we've simplified, we have the same index and the same radicand, so we can simplify. 5 plus 3 minus 2 gives us 6 cube root of 2.